Um, all right, I think now I'm recording. Yes, yes, I'm recording. Thank you, Edward. I don't know why I forgot about it. But anyway, yeah, so you're right. So yeah, so this number, which is between 0% and 100%, describes the likelihood that an event describes the likelihood that the event will occur. Okay. Again, here by occur, of course, I mean happen, will happen, right? Will take place. And of course, if your probability is 100%, so if, for example, examples. So when we say like the probability of an event A is equal to, let's say 100%, probability of an event. If you say this is 100%, right? And as I said, 100% means 100 over 100, and 100 over 100, that's equal to 1. So if the probability of your event is 100%, it means that you're certain that the event will occur, right? So the event, it means that there is 100% chance that the event will occur, right? So in other words, that the event is going to occur, right? So then the event will occur. Okay. So you're certain that that the event is going to occur. If your probability, of course, is 0%, so if you have an event and you know that the probability of the event is just 0%, okay. So if so this is the first example. Second example, if let's say the probability of an event A is 0 or 0%, right? 0 is the same as 0%. Of an event is 0 or 0%, okay, then it means that there is no chance, right, for the event to occur, right? The event won't occur, right? So there is no chance. So then the event will not occur. Okay. Anyway, so again, the idea is, so what you need to keep in mind, guys, a probability is always a number between 0 and 0% and 100%. Okay. If you compute a probability and your answer is not between 0 and 1 or 0% and 100%, then you made a mistake. Okay. It's always a number between 0 and 1. Okay. Or 0 and 1%, 100%. Now, just I'm going to discuss some notation here. So, so actually, we denote the probability of an event notation. So when we write P, right, capital P of A, okay. So the capital P stands for probability. Okay, capital P means a probability. So that's a probability. Okay, that's my capital P. So capital P of A. So that's the probability of the event A. Okay, so this is the probability of the event A. Okay, so again, the capital P.
I have a question.
Yes, please.
Why would you make probability, when you spell probability, you're making it a small p? Does that matter or no?
No, it doesn't matter. I mean, it's just it's just a conversion. We use a capital P, but if you use lowercase.
No, because I wouldn't want lowercase to mean like a negative and a big P positive.
Yeah,
so lowercase the same.
Yeah, it's the same. I mean, I don't.
Right.
It doesn't matter. But it's just, it's just a convention that we use this capital P for probability. But of course, if you use the lowercase, it's not a problem. I mean, yeah. Yeah. So yeah. So this capital P stands for this is probability. probability. And then A, that's my event. Okay, so this is probability of the event A. Okay, so when I say, for example, so if you say P of A is 100%, so that means probability of the event A is 100%, right? So the event A will definitely occur, right? So this is, so it means probability of A is 100%. So in other words, so then the event A will occur. Okay. All right, now, how do we compute the probability of an event A in general? Okay, that's the next question, right? So question, how do we compute the probability of an event A? So how do we compute the probability of an event A? Okay. Well, the formula is it's actually based on relative frequency. Remember, in our in our frequency tables, we had the frequency, the relative frequency. So the relative frequency, that's actually the probability of your interval, or the probability of your event. So the answer here. So the probability is based on the relative frequency of the event. So the probability of A, okay, this is equal to the frequency of the event occurrence over occurrence, right? Remember, the relative frequency, guys, was like the frequency of over divided by the size of the sample. So here the same thing, we divide by the size, the total size of the sample. So we divide by the total size of the sample. Okay. So again, the probability of the event A, that's the frequency of the event A, the frequency of the event A over the size of the sample. Okay. An example. Let's do an example. All right. So let's say we have a random sample of 500 students. Of 500, say we have 500 students, okay? And then, so the 500 students, let's say they were surveyed. And it turns out that, let's say 375 students wear glasses. And actually 375 students wear glasses. Okay, so out of the 500, 375 students actually they wear glasses. Okay, the question is estimate the probability. So what will be the probability that a random student, right, wear glasses? Okay, so estimate the probability that a random random student wears glasses. Okay. All right. So first, let's try to understand this example, right? So I'm looking for the probability, right, that a random student wear glasses, right? So what's the event A here? So we're interested in, the students wearing glasses, right? So my event A, my event here is, so A would be, so the event A. So this is when a student wears glasses, right? That's my event A, right? I'm looking for the probability that a random student wear glasses, right? So the event here is that a random student wear glasses, right? So the event A is that the student wears glasses, right? So the random student wears glasses. Okay, that's the event. Because I want to find I'm interested in the probability that the student wears glasses, right? So my event A would be that the student wears glasses. Sorry. All right. So to find I want to find the probability of A, right? Probability that a student, probability of A. So I want to find the probability that this is the probability. There's a question in the chat, I think. Thank you, Niva. I think I have a kind of a cold. I got or a flu or something. Anyway, so this is a probability of course, the probability that a student wears glasses. All right. So what does it say in the formula? It says the frequency of the event occurrence over the size of the sample. Okay. Don't forget, in the probability, guys, it's a fraction, right? So we have it's a fraction. So we have the frequency in the top, and then we need to divide by the size of the sample. So you need to divide. So like in this case, what's the size of my sample? I have a sample of, it says we have a sample of 500 students, right? So the size of the sample is 500 students. That's the size of the sample, right? So we need to divide by 500 because that's the size of my sample. That's the size of my samples, the size of the sample. Right? Because we have a sample of 500 students. Now, out of the 500, how many wear glasses? Well, it says we have
375.
375, right? So that's the frequency of the event occurrence. So the frequency of the event here is 375. And so the 375, that's like the frequency of the event occurrence. It's the frequency of the event A. So out of the 500, we have 375 students wearing glasses, right? So that's my probability. It's 375 over 500. Okay. Now we need to divide. Okay, so we need to divide the 375 by 500. So P of A is equal to, so as we said, it's 375 over 500, right? And that will be equal to, so when you divide, it's actually 0.75. Okay, so when you divide 375 by 500, if you use your calculator, you divide 375 by 500, you're gonna get 0.75. Now, you wanna convert this to a percentage, okay, 0.75. Okay, so the way to convert a decimal to percentage, all you have to do, guys, is to multiply by 100. Okay, so what we do here, so I want to convert. So at first, as you can see, this 0.75, that's a number between 0 and 1, right? That's between 0 and 1. Okay. And that's exactly what we said about probability. It's a number between 0 and 1. So my answer here makes sense because I got a number which is between 0 and 1, right? Now, you need to convert your answer to a percentage, okay? And the way to convert your decimal to percentage is just you multiply by 100. Okay, so you multiply. To convert the answer to percentage, just multiply by 100. Multiply by 100, and of course you need to add the percentage symbol, and add the percentage symbol. So like here, so our answer is, we said it's 0.75, right? So what we do, just multiply by 100. So this is 0.75 times 100. All right, and then there's this percent. So 0.75 by times 100, that's 75, right? So the probability of the event A is just 75, right? That's, again, that's my 0.75 times 100. That's 75. And then I have, of course, the percentage symbol, right? So then I have my percentage symbol. So here's my percentage symbol. So here's my final answer. So the probability of this event A is 75%. Okay. So again, to compute the probability, it's given by the frequency of the event over the size of the sample. Now, once you divide, you're gonna get some decimal. Now you need to convert your answer to percentage. Okay. And the way to convert to percentage is by multiplying by 100 with, of course, with the percentage symbol. Okay. Any questions so far? All right, so let's do more examples. I mean, today I'm gonna do a lot of examples, right? This is again, it's gonna be just an introduction, right? Very simple probabilities. We're gonna do a lot of examples, just to make sure that we understand what's a probability and how do we compute the probability in general, right? Now, let's say you're gonna roll a die. So example number 2. Okay, this is example number 1. So example number 2. So now let's say we roll a die. Okay. And the question is, so what's the probability? What's probability to get, let's say, the number 4? Okay. So to answer the question, okay. So the event A here, so I'm interested in the probability to get the number 4, right? Of course, in the die you have, so numbers are from 1 to 6, right? So, and here, so the event A, so the event, so the event A here,
everything.
Sorry, is that a question for me? Sorry.
Okay.
Okay, probably not.
Thank you.
need to meet someone.
1550.
Yeah, dice. Yeah, that's the same thing. Yes. Yes. Yeah, the dice, that's a die. Yeah, that's the same thing.
About 360.
So,
Just 15.
Yeah, 165.
okay, I think I muted the, okay, all right. Yes, Nivelle, yeah, die or dice is the same thing. Yeah. So an event A here in this case would be to get the number 4, right? That's what I want. We want the probability to get the number 4. So the event A would be to get the number 4. Okay, and so of course the number 4. So we have, of course, we have 6 possible 6 possible numbers, right? From 1 to 6. 6 possible numbers, right? From 1 to 6. 1 to 6, right? So then the probability of the event A in this case, right, to get the number 4, that's one. So number 4 is, of course, it's just one number out of 6, right? That's one number out of 6. So the probability of the event A here, it's 1 out of 6, right? Because 6, that will be the size of their sample. You have 6 possible numbers, right? And number 4 would be just one possible number out of 6. Okay, so that's the probability of the event A here is just, so this is because we have 6 possible numbers. Okay, and in the top we have 1 because 4 is just one number, right, out of 6. So yeah, anyway, so if you divide 1 by 6, of course, so probability of the event A, it's 1 over 6. So if you divide 1 over 6, of course, you're gonna get.
Don't live around me and mines. No, you don't need to be on a voucher with me and my kids.
Okay, I guess I need to mute Kayla. All right, so yeah, hi Kayla. So 1 over 6, that's 0.16, let's say 6, okay? And then we need to convert this answer to percentage. So convert to percentage. So we multiply by 100, right? Just multiply by 100. By 100, right, percent. So 100 times, so this is like 0.166 times 100, and then there's a percent, right? So then P of A is just 16.6, right? That's 0.166 times 100, that's 16.6, and then there's a percent. All right, so that's the probability of the probability of the event A. You see the board, right, guys? I don't think there's a problem with the board. Right? You see the board, right?
Yeah.
Okay. Okay. Perfect. All right. So, okay, let's do more examples. I have here some exercises. So let's do an exercise. Exercise number 1. Okay. So let's see. Exercise 1, it says the vote. So let's say John runs a store. Okay. And yesterday, so yesterday he counted, let's say 127 people, 127 people who walked by his store, who walked by his store. Okay. And 58, and actually 58 of whom they came into the store. So 58 out of the 127, they came into the store. And then and of the 58 who came into the store, of the 58, only 25, let's say, only 25 they bought something. Okay, so we have 127 people who walked by the store. Out of the 127, 58 came into the store, and out of the 58, only 25 bought something, right? So the question is the following. So first, find the probability that a person who walks by the store, the person who walks by the store, will enter the store. B. So find the probability that that a person who enters the store will buy something. C. So find the probability that a person who walks by the who walks by the store will buy something. Okay. All right. Okay, so let's do this exercise together. Okay, so I'm gonna try to explain the A, B, and C. Okay, so let's start with the A. So first thing, we need to find what's the event A in the event in A, right? So in A, we need to find the probability that a person who walks by the store will enter the store. Okay. So the event here is that the person will enter the store, right? So find the probability that the person who walks by the store will enter the store, right? Enter the store, that's the event. Okay, so in A, here, the event A is the person enters the store. Right? So we are looking for the probability that a person enters the store, right? So what's the probability that a person who walks by the store will enter the store, right? So this is a probability that a person who walks by the store will enter the store. Who walks by the store will enter the store. All right. So what's the size of the sample in this case?
127.
127, because that's the size, because we have 127 people who walk by the store, right? So we are interested in the people who walk by the store. We have 127 people who walk by the store. So we need to divide by 127, right? So it's 127, very good. So that's the number of people who walk by the store. That's the number of people who walk by the store. Now, walk by the store. Out of the 127, how many enter the store?
58.
58, very good. So in the top, the frequency of the event is 58. Again, the event is that a person enters the store. So the frequency of the event is 58 because we have 58 people who entered the store, right? So the 58, that's the number of people who entered the store. Who entered the store. Right? So what we are saying here is out of the 127 people who walked by the store, 58 entered the store, right? That's exactly so that would be my probability of the event A. Okay. So again, it's the frequency of the event. The event here, we are interested in the people who entered the store, right? That's what we want, the people who entered the store, right? And the size of the sample, that's the people who walked by the store. Okay. Yeah. Yeah, so then if you divide, of course, 58 by 127, let me see, it's 0.46, right? And so we want to convert this to percentage, just multiply, convert to percentage. So just multiply by 100%. Multiply by 100. And then just add the percentage symbol. So that's 0.46 times 100. Then we have percent. All right, so that's 46%, right? That's the probability of the event A. That's 46%. Any questions so far, guys? And again, the thing is, your answer, if your answer is not a number between 0 and 1, then it means you made a mistake somewhere. Okay, so probability, it's always a fraction, right? So we have like a frequency in the top, the frequency of the event over the size of the sample. Okay, so it's always a number between 0 and 1. All right, so now next for B. So what will be the event in B? What's the event here? Let's see.
It
So
would be 58 over 25, no?
yes. Well, probably the other way around. So 25 over 58. So the event here is that a person, right? So find the probability that the person who enters the store will buy something, right? So the event here is that the person will buy something. But what's the size of the sample? What's the sample here? So sample here is the people who entered the store. That's my sample, right? So out of the 58 people who entered the store, 25 actually bought something, right? So the sample is the people who entered the store, right? And the event is that a person will buy something. So the event is that a person. The event is that event A here is that a person will buy something. Buy something. Right. And the sample here, just because it's different from the previous question, right? So here, the sample is not all the. I mean,
Professor?
yes.
Hi, so I have to leave class early. I have my inspectors here.
Sure, no problem. Thank you
I'll
for
take
letting me
the
know.
rest of the notes from the YouTube. Thank you.
Thank you for letting me know. Thanks. Yeah, so the size of the sample here, guys, just be careful. So this is different from A. In A, the sample is all the people who walk by the store, right? A person who walks by the store, that's my sample. In B, the sample is given by the people who entered the store. So probably that the person who enters the store will buy something. So the sample here would be the people who entered the store. Okay, so the sample here, that is the people who entered the store. Okay, so yeah, so then the probability of the event A, the frequency of the event. So how many people bought something? Well, we know it's 25. 25 bought something. So the frequency is 25. 25 over. Now the sample, it's not all the people who walked by the store, it's just the people who entered the store, right? It says who entered the store. So just the people who entered the store. And we have 58 people, right, who entered the store. So that's 25 over 58. But anyway, you know, guys, if you do 58 over 25, you're gonna get some number. Actually, you're gonna get like 2 point something. So you're gonna get the number which is actually larger than 1. So that it means like there's something wrong here. If you divide 58 by 25, you're gonna get a number like you're gonna get 2 point something, right? So you're gonna get a number which is not between 0 and 1. So this is not between 0 and 1, so it means we made a mistake somewhere. So there's something wrong somewhere, okay? Not between 0 and 1. So in general, guys, like in the probability, the number in the top is supposed to be less than the number in the bottom, okay? So in general, the number in the top is always less than the number in the bottom, okay? So, okay, so let me write it down here. So in a probability, I mean, you can just take it as a rule. Okay, in a probability, the number in the top is always less or equal to the number in the bottom. To the number in the bottom. Okay, because the reason is, of course, because the size of the sample is always larger than the frequency of the event. Okay, so 25 out of the 58 bought something, right? It's not the 58 out of 25, it's 25 out of the 58. Okay. So yeah, so it's 25 over 58, and when you divide 25 by 58, then the answer would be where is it? It's 0.43. So you see, the answer is it's a number between 0 and 1. Okay. Converted to percentage, so you multiply by 100%, right? Like 0.43 times 100. and then there's a percent. 0.43 times 100, of course, it's 43. So that would be 43%, right? So the answer here, okay, 43%. Make sense to you guys? All right, so again, just keep in mind, you have, it's a probability, you're gonna have like a fraction, you're gonna divide. There's a number in the top, there's a number in the bottom. The number in the top is always less than the number in the bottom. The bottom is supposed to be the size of the sample. The top is supposed to be the frequency of the event, okay? And of course, the event and the size of the sample depends on the question. So we have to read very carefully the question, okay? You need to, you need to know exactly what's the event, what you are interested in, right? And what's the sample. So for example, for the C, let's do the C. And then I will give you a couple of exercises, guys, so we can practice a little bit. So the C. So what are we interested in the C? Well, it says probability that a person who walks by the store will buy something. So the event here is that the person who walks by the store will buy something. So the event is that the person will buy something, right? That's my event. This is my event. Is that a person will buy something, right? That's the event. Now, what's the sample here? Is it like the people who entered the store or the people who walked by the store? Well, walk by the store, right? It says the people who walk by the store, right? Who walks by the store. So the sample here, the size of the sample, that will be the 127, right? Because we have 127 people who walk by the store. So yeah, so the event is that person will buy something. A person will buy, sorry, a person will buy something. And the size of the sample here would be the people who walk by the store. People who walk by the store. All right, so then the probability of the event A, my event A. So frequency of the event A, we have 25 people who bought something. So that's 25 in the top, over the size of the sample. That's the number of people who walk by the store. And we know there are 127 people who walk by the store. So it's over 127. So this is different from the previous question, right? The previous question was, it was 25 over 58, right? So now we have 25 over 127. That's not the same thing because we have two different samples, right? In the previous question, the sample was the people who entered the store. And now in C, the sample, that's the people who walked by the store, not the people who entered the store, but the people who walked by the store. Okay, so we have two different answers, right? Because it's two different denominators, right? Anyway, so 25 by 127, that's well, approximately 0.20. Okay, and converted to percentage, that's 0.20 times 100%, right? That's 0.20 times 100, and then there's percent. 0.20 times 100, that's 20, and then there's percent. So the answer is 20%. Okay, so the probability that a person who walked by the store will buy something is 20%. All right, guys. So let me give you an exercise. All right, we have plenty of exercises. We need to practice a little bit because this is a new, this is a new notion for you. This notion of probability. So we're gonna practice a little bit before moving to the next next section. So exercise, and I'm going to give you some time to think about this exercise. All right, so so let's say we have a survey of when crimes are committed in the Bronx. So let's say, so here's the time. And here it's the number of crimes. All right, so let's say from 6 a.m. to 12 p.m., from 6 a.m. to 12 p.m., the number of crimes is 290. Let's say in a last year, okay? Let's say here is last year. And then from 12 p.m. to 6 p.m., the number of crimes is 135, which makes sense. Like this is the afternoon, so we're gonna have like less crimes committed, right? In the afternoon, I guess. And then from 6 p.m. to 12 a.m., we have 319 crimes. And then from 12 a.m. to 6 a.m., we have like 222 crimes. So the question is, so A, B, C, A, B, C, D. So we need to estimate the probability or find the probability that in A, find probability that a crime that the crime is committed between let's say 6 a.m. and 12 p.m. Same thing for, so find the probability that a crime, let's just do A, B, and C. So find the probability that a crime is committed between, let's say, 6 p.m. and 12 a.m. Last one. Let's do the interval. So 12 a.m., 6 a.m. Okay, so find the probability that a crime is committed between 12 a.m. and 6 a.m. Okay. All right, guys, I'm gonna give you a couple of minutes to think about this exercise.
Just to verify that C, you put 12 a.m. to 6 a.m.
Yeah, 12 a.m. to 6 a.m. Yes.
Okay, thank you.
Yes. So again, just remind you the probability that will be the frequency of the event. So I mean, how many times the event occur, right? Over, of course, over the size of the sample, over the total number or the total size of the sample. In your final answer, guys, please, you need to convert your answer, which is probably decimal, to a percentage. So like in the homework on the test, you need to convert your answer to a percentage. You know, that's because like in general, when we talk about probability, it's always as, you know, it's always like given by a percentage. Like I would say there's 50% chance that something happens, right? Or I don't know, 87% that something happens. So it's always like a percentage, right? I think the problem here, in this exercise, is the, you know, the size of the sample. So just be careful with the size of the sample. So what's the total size of the sample? That's probably the main question here. I guess the
Is
frequency
it
of
4?
4, you said?
Yeah.
But then, for example, what would be the answer for A? We would say it's 290 over 4.
Yeah.
But then remember what I said, you know, in a probability, the number in the top is always supposed to be less than
yeah.
the number in the bottom.
Would
So,
you add the number of the crimes, all of the numbers?
yes, yes.
Okay.
So that's, yes. So the size of the sample here, that's the total number of crimes. The
Oh,
total
so the
number of
mean
crimes,
of the crimes.
not the mean, but the
Oh,
total number of crimes. Like, so you have like 290 crimes between 6 a.m. and 12, right? p.m. And then you have 135 between 12 p.m. and 6 p.m., etc., right? So then the total of number of crimes would be the 290 plus the 135 plus the 319, you know, that would give you the total number of crimes.
oh, okay. All right. Because you know what? I was late today.
I mean, that's a good point, because always keep in mind when you compute the probability number, your number in the top is always less than the one in the bottom. So if you get something which is like 290 over 4, that doesn't make sense, because of course 290 is larger than 4. Yanine, you're saying A would be 2%. I don't know why you got 2%. There's something, I think there's something wrong here with your answers, Yanine. I don't. Jessica, you're saying 30%? Yes. For the number one, yes. Jessica, you're right. The answer would be 30%. That's very good.
Doesn't it equal to 6 hours?
No, that's not. You see, yeah, that's a good. Okay, you see the size. We are interested in the you know in the probability that a crime is committed like between like 6 a.m. and 12 p.m. right? But
Right.
the
I
size of the
calculated
sample.
hours.
It's not the hours here. It's about the number of crimes, right? It's not about the number of hours. It's about the number of crimes. So in total, when I say the size of the sample, that will be like the total number of crimes. So the hours here, they don't really matter.
So what will we do with the 190? We have to, obviously, that will be the bottom number divided by what number?
No, the 290, that will be the number in the top. That's the frequency, that's the number of crimes. So that's the number of crimes of between 6 a.m. and 12 p.m. Now, what's the bottom? That's the total number of crimes. What's the total number of crimes?
Got it. Okay.
So it's here, yeah. So here it's about
You're talking about all the crimes that we have.
yeah,
on the-
all the crimes, yeah,
Right. Okay.
all the crimes. That's the
That
total.
I was
crimes.
doing the amount of hours. That's
Yeah, I
why.
know. Yeah.
Is the first answer 30?
Yes, the first answer 30%. Yes.
Oh,
Great.
okay.
Yeah.
Thank you.
Mhm. And it makes sense, right? I mean, it's like 290. It's you have 290 crimes between 6 a.m. From 6 a.m. to 12 p.m. out of some number of crimes, right? Out of it's supposed to be the same the same population. If we are talking about crimes in the top, then the denominator is also some number of crimes. Okay, you cannot just like divide crimes by the number of hours. Doesn't make sense because you are using two different units. So if you are talking about crimes as a frequency, the size of the sample, it's also about crimes. Nival, you're saying 33%. Let me see my notes. 6 p.m. to 12. Yes, 33%. Very good, Nival. Yes.
Would you round up the last one to 30%?
I mean, you don't have to round up your answers, but yes, I mean, you can do that. That's fine too. Yes. So, what did you get for last one?
It was point 229.
Okay,
So
yeah,
you
you round it.
round up.
Yeah, if you round it,
Yeah.
if you round it, it will be 0.23. Yes, yes. I mean, both answers are correct for me. I mean,
So for the top, it's the amount, it's the sample value that's on the top.
no, the top would be like the frequency, the frequency of the event. So like here we're talking about the crimes committed between 6 a.m. and 12 p.m. right? So we have 290 crimes, right, committed between 6 a.m. and 12 p.m. So that's like the frequency of the event. You count how many times if the event occurred, right? So 290, that's the top. That's that's the frequency of the event. But then you need to divide by the size of the sample. So you have 290 crimes out of how many crimes, right? Well, the denominator would be like the total number of crimes. So then you need to add, all the crimes here from.
Oh, okay.
Mhm.
All right, because I missed like the whole thing. So then you do the side, okay, and then you divide by
Mhm.
I gotta watch the video. I get what you're saying. I just can't explain it.
Yeah, so you just add, so the bottom will be like 290 plus 135 plus 319 plus 222. So that's like the total number of crimes during the whole day. Yes, Nival, that's correct. Yes. All right, guys. Because we're gonna do more exercises, so let me just go over this. And again, I understand this is I guess I mean it's still confusing, but let me just say, like for A, so the probability of the event A. So what's the event A? The event is that a crime is committed between 6 a.m. and 12 p.m. So we know that from 6 a.m. to 12, we have 290 crimes committed, right? So the top, that's 290, because that's the frequency of the event. How many crimes committed between 6 a.m. and 12 p.m.? That's exactly what I mean by the frequency of the event. How many times, you know, the event occurred, right? 290 times, right? Over, now the denominator, that's supposed to be the size of the sample. So 290 crimes out of how many crimes? So the top and the bottom, guys, use the same units. So if in the top we are talking about crimes, 290 crimes, then the denominator is also, the units is also crimes, the same units. So if you are talking about crimes in the top, 290 crimes, you divide by some number of crimes, okay? Same units. We're talking about the same population, right? So here we're talking about crimes. So that's 290 crimes over out of how many crimes in total? So in total we have, so it's 290. That's from, you know, from 6 a.m. to 12, plus we have 135 from 12 to 6 p.m. and then plus 319 from 6 p.m. to 12 a.m. and then plus 222 sorry, 222 from 12 a.m. to 6 a.m. So in total, we have 966 crimes. That's a sample of the size of the sample. It's 966. So in total, we have 966 crimes. So in total number of crimes, total number of crimes. Okay. So yes. And as you can see, denominator, the number in the bottom is larger than the number in the top. So 290 over 966, it's 0.30, right? And then you multiply, convert this to percentage, you multiply by 100%. So multiply by 100, that's 30, and there is a percent. Don't forget the percent, right? That's 30%. All right, B, the idea is the same, of course. It's just a different, it's just a different time interval. So in B, the interval is from 6 p.m. to 12 a.m. So from 6 p.m. To 12 a.m. Of course, we have 319 crimes. So the probability of my event. So we have 319 crimes from 6 p.m. to 12 a.m. And again, the size of the sample, that's the total number of crimes. So we divide again by 966. 319 over 966, it's 0.33. And then convert it to percentage, we multiply by 100%. So to multiply by 100, that's 33. And then there's my percent. So the answer is 33%. C, the idea is the same. Now in C, we are interested in the number of crimes committed between 12 a.m. and 6 a.m. So 12 a.m., 6 a.m., it's just right here, 12 a.m., 6 a.m. So we have 222 crimes. Out of how many crimes in total? Well, in total, we have 966. So that's 222 out of 966. And again, keep in mind, guys, the top and the bottom, they have the same units. So if you are talking about crimes in the top, you need to talk about crimes, number of crimes in the denominator. Okay. So that's why it doesn't make sense like to divide by the number of hours, like divide by 4 or divide by 6 hours, or you need to use the same units. And actually, you know, in the probability, because you're using the same units in the top and the bottom, then the units, they cancel out. So the answer is actually independent of your units. When I say 33%, there's no units in 33% because we are using the same unit. So if in the top it's crimes, units is a crime, number of crimes, and the units in the denominator is the number of crimes. So crimes over crimes, they cancel out. So then it's the percentage, your probability is just it's independent of units. It's independent of the crimes, right? So yeah, so 222 crimes over 966 crimes. So that's 0. If you round up your answer, 0.23 multiplied by 100, that's 23. And of course, there's my percentage. So, all right. No question, guys. All right, so let's do another exercise on the same. Well, I mean, it's again about probability, of course. Exercise 2, I guess. So we have a survey of 200 couples. A survey of 200 couples. Okay. So here in this table, we have number of couples, and then you have the number of kids. Okay. So let's say you have 80 couples with 0 kids. Okay, so this is here I'm saying we have 80 couples with 80 couples. With 0 kid. All right. And then we have 40 couples with 1 kid. Okay. And then we have 30 couples with 2 kids. Okay. And then we have 20, let's see, this is 50. So we have 30, sorry, 25 couples with 3 kids. Okay. And then 20 couples with 4 kids. And then just 5 couples with 5 kids. Okay. So of course, in total, we have 200 couples, right? I mean, 80 plus 40 plus 30 plus 25 plus 20 plus 5. So the total number of couples here is 200, right? We have a survey of 200 couples. All right, guys. So we need to find the probability that a random couple, so a couple selected at random, so A, so find the probability that a couple selected at random has 3 kids. B, find the probability that a couple selected at random, I mean, a random couple has let's say 4 kids. Okay. We can add another 1 plus 1. C. Again, find the probability that a couple, again, random couple selected at random has, let's say, 1 kid. All right. So don't forget, it's the frequency of the event over the size of the sample. All right, guys, you have a couple of minutes to think about this. I mean, well, I think if you know how to solve A, then probably B and C are very similar to A. So if you know how to answer A, then you are good for B and C. So frequency of the event. So you count how many.
Professor, how many
Yes.
for C? How many kids for C? Fine. Couple selected random. I can't see the rest.
Oh, sorry, one kid for C.
Oh, one kid. All right, thank
Sorry,
you.
it's one. Yeah, it's sorry. Sorry. All right, guys, any guess for, I'm sorry, because we don't have much time. Any guess for A? Any, you're saying 13%?
I
Oh,
mean,
okay, you rounded your answer, right?
right, because it's
Okay.
it will be 12.5%.
Yeah, it will be 12.5%. Yes, thank you.
The next one I had 10% and the
Yes,
C 20%.
yes, very good. Yes, very good. Yes, so yeah, you got the idea, guys. I mean, just be careful. Yeah, I mean, just one thing again. Your top and your bottom in your when you compute your probability, they have the same units, right? So if we are talking about number of couples, like in the top, the size of the sample, it's also about number of couples. Okay. So all right. Okay, I have like 2 minutes just to write down. I guess that would be just enough to write down the answer here. So yeah, so for A, guys, let me just say for A, the probability of the event A. So we are talking about, so find the probability that a couple selected at random has 3 kids, right? The event here is that a couple has 3 kids. What's the frequency of the event? How many couples have 3 kids? Well, how many couples with 3 kids? We have 20, oops, sorry. We have 25 couples with 3 kids, right? So the frequency of the event here is 25. That's the number of couples with 3 kids. That's the frequency of the event. So we have 25 couples. So that's 25. That's the top. That's the frequency of the event. That's the number of couples with 3 kids. With 3 kids. All right, now 25 out of how many couples, right? So 25, the total size of the sample, we have, in total, we have 200 couples, right? So that's 25 out of 200. So it's 25 couples out of 200 couples, right? So we need to divide by 200. That's the size. That's the size of the sample. All right. So yes, so then 25 couples over 200 couples, that's 25 over 200, so that's 0.125. And when converted to percentage, we multiply by 100%, so that's 12.5%. Okay. In just 30 seconds, I'm gonna just write down the answers for B and C. So the idea is the same. It's just the number of couples, of course, in the top is gonna be different. So like in B, we are talking about couples with 4 kids. We have 20 couples with 4 kids. So that will be 20 in the top. And again, the size of the sample is again 200. So that's 20 couples out of 200 couples, right? So that's 20 over 200. So that's equal to, of course, let's see, the 10%, so 0.1. So that's multiplied by 100, right? So that's 10%. Okay. Last one, we are talking about couples with 1 kid. With 1 kid, we have 40 couples with 1 kid. So that's 40 out of 200 couples, 400. So sorry, 40 over 200. 40 over 200, that's 0.20. And multiplied by 100%, that's 20%. Okay. All right, guys, I'm sorry, went over time, but I'm gonna stop here. So next time I'm gonna, of course, continue the probability, but yeah, this is like, again, this is just an introduction, right? But hopefully you got the idea here. All right, thank you for listening, everyone, and hopefully I'm gonna see you on next Monday.
Professor, you said the homework number 4 is posted already?
No, I'm gonna post it tomorrow.
Okay.
And I'm gonna post it tomorrow. So as usual, it's gonna be due like Thursday next week.
Okay. All
Mhm.
right, thanks.
So
Thank you,
the
Professor. Have a nice one.
homework would be like a review of the test, or what's the homework consist of?
No, so the homework is gonna just cover like the last lectures, but
Oh,
as I said, next week I'm gonna post a review sheet which is gonna cover like everything we have seen in the right.
Got
So the
it.
review
Okay.
sheet will cover everything you're gonna have to test, but the homework is just it's about the last lectures.
Okay.
Mhm.
All right. All right. Thank you, Professor. Take
Sure.
care.
Take
Bye,
care.
Professor.
Bye, everyone. Take care.
Bye. Have a good weekend.
You too. Take care, everyone.